So now if we have the limit as x approaches 1 of our function x cubed minus x over 1, of course, I'm going to use direct substitution in for all of my x's. And that gives me 1 cubed minus 1 over 1 minus 1, which gives me this indeterminate form, which tells me right away I have a hole. As x approaches 1, so at 1, I'm going to have a hole. So plan A failed. A failed. So I better have a plan B. And again, our plan B will be to factor and then cancel. And then we're going to use direct substitution. So if I have the limit as x approaches 1 of, well, I can factor out an x here. And I'm left with x squared minus 1 over x minus 1. Good thing that x squared minus 1 is a difference of perfect squares. So I have the limit as x approaches 1 of x times x minus 1 times x plus 1 over x minus 1. Now, because this is all multiplication, I can cancel. I can't cancel across an addition subtraction, but this is times and this is times. So that allows me to do it. And so my surviving function after I cancel is x times x plus 1. Now, if you cancel in a rational function like this, rational, think that means fraction. If you cancel x minus 1, whatever you cancel, set it equal to 0, and that will tell you your x of the whole. So if you remember from our previous courses, cancel x minus 1 means there's a hole at x equals 1. Of course, a hole is an xy point, so that only gives us that we know there's a hole at 1 some y. And the way we find that y is to do direct substitution into this surviving function. 1 times 1 plus 1 is 1 times 2 is 2. That is the limit. This is the limit. Y is trending towards 2. Here's the bonus. Where's the hole? The answer to this question is 2. The hole is at, well, x is heading towards 1, well, y is heading towards 2. So our hole is at 1, 2. If you're ever asked about the hole, well, look, x is heading here and y is heading here. That's what the limit means. In this particular problem, of course, plan A is always direct substitution. 3 squared minus 8 times 3 plus 15. We have to do PEMDAS there, parentheses, exponents, multiplication, division, addition, subtraction, left to right. And then 3 squared minus 9. Well, this gives us 9 plus 15 minus 24, which is 0 over 0. So right away, I know this indeterminate form means I've got a hole at x equals 3. But of course, I need to find the y coordinate of that. I already know there's a hole, though. So my plan B, of course, I've got to have a backup plan. And that is going to be factor, cancel, and then use direct substitution. So limit x approaches 3. Good thing I know how to factor this into the product of two binomials, and this is a difference of perfect squares. The bottom is easy, x minus 3, x plus 3. The top is x times x, and then factors of 15 that add to negative 8, that's negative 5 and negative 3. Because this is all multiplication, my surviving function that I take the limit of is x minus 5 over x plus 3. And if I now use direct substitution, and I put in here and here, I'm going to have 3 minus 5 is negative 2, and 3 plus 3 is 6, which simplifies, if I divide by 2, negative 1 over 3. That is our answer. Now, where's the hole? I knew there was a hole because I got a 0 over 0. As x heads towards 3, y is heading towards negative 1 over 3. Don't forget, the trend in y is our limit, and they asked us for the limit. So that's why the y value of that hole is the limit. And we say the limit is not reached because we had a hole there.